the one hint, the one clue I gave you that might have let you do homework over the weekend, even though we had not done those yet. Horizontal asymptotes. If horizontal asymptotes exist, this is how we find them, as limits at infinity. And horizontal asymptotes, was it or was it not in your summer review packet?
It was.
It was. And how did you solve them in pre-cal and or in a summer review packet? Solve 4 times. Degree test. What? Degree test. So we're getting to the degree test, but first of all, I don't know if I'm necessarily going to make you guys plug in an example per se. No, let's do it. Okay, what if I was to give you something like, calculators out, I want you to go to your tables. Calculators out, I want you to go to your tables. What if I was to give you the limit as x goes to infinity? Oh dear, I need to orient the screen. Let me have you guys with 2 different examples that you're plugging into your calculator because I want you to see something. Remember, our calculators are our last resort, unless you have a nasty word problem, a nasty function. That's a calculator problem. But that's okay. I still want you to see your table feature. What should your table setup be? Second window? Automatic or ask if we're putting in stuff like that? Definitely. For the independent or the dependent part? Independent for the x's.
The dependent stays on.
Yeah, just stay in. Because auto dependent says to get your y, I'll plug in the x. Otherwise it gets so confusing. Let's see. I want to go to positive infinity because that's what my table is set up for. You didn't have to choose these. We just did because it was in your homework. Let's go ahead and do, yeah. Let's do x. No, I don't want that. Yes, I did. No, I did. Hold on. Yeah. Okay. The square root of x to the 4th plus 1, all in the denominator of x squared minus 7. There you go. Let's do that one first. X to the 4th, sorry. X squared minus 7, all over the square root of x to the 4th plus 1. And then the other one, let's go ahead and do the limit as x goes to negative infinity. Of 5e to the x all over 7 minus x to the 10. You guys have the 2 examples written down? Calculators out. If you don't have your calculator, you're looking on with someone in your group. Okay, because I'm going to orient the screen. They're all here. So going to positive infinity by adding zeros, going to negative infinity by adding zeros to negative numbers. Good?
10.
Oh.
Click, Misty. Why do you have to slide?
Technically, you have more precision when you slide. When we first got the smart boards, there was a person who came and taught us. And if you just tap it, you could tap like a little bit on the outside, but if you slide it, you can slide it to precisely the center.
Oh.
If that makes sense.
Didn't know it did that.
So what are you guys seeing in the first one? When you guys plug in, what are you guys getting out? Numbers? What kind of numbers?
Wow.
Huh? Is that for 30 or for 30,000? 30. Okay, so 1.00? Keep going. How about 300?
How many decimals?
Just give me as many as you can. How about 3,000?
6 zeros, 6 sevens.
How about 30,000?
Wow. 8 zeros, 4 sevens.
Question, what's happening to your function as you continue to have x's approach infinity?
Closer and closer to 1.
It's getting closer and closer and closer to 1. And in context of what Kathleen said at the beginning of class, what is existing at 1 due to this function stabilizing, converging to, approaching 1 as x approaches infinity? What kind of asymptote?
Horizontal line.
Because remember, isn't every limit finding a function value? A y value, a height that the function is approaching? So there's a horizontal asymptote at y equals 1 because the limit as you go to positive infinity. Hold on. If you still have that function in your calculator, can you go through to your table and change them all to negatives? My question is, does the horizontal asymptote exist in both directions? Because it's not always true. It's not always true. Either sometimes you have a horizontal asymptote only in one direction, not in the other, or you have one horizontal asymptote one way and another horizontal asymptote the other way. Not always, but sometimes. Did anybody plug in negatives? Is it still approaching 1?
Yeah.
Good.
Yes.
Okay, so this one happens to have a horizontal asymptote. Whether you go the positive infinity direction or the negative infinity direction, you are going to be approaching 1. But how could we have done that algebraically, analytically, without a table?
Degree test.
Degree test? What do you mean? How would you get 1 out of this? They're different. Bottom wins. Isn't that a 0?
Or does it?
No.
Why does the bottom not win? Why is this a ratio of leading coefficients? The square root of a 4th degree polynomial is what kind of polynomial? A squared. The square root of a 4th degree polynomial is a squared polynomial. Now hold on. Can we say that the square root of the bottom is x squared plus 1?
No.
No. We kill the puppy. Because I cannot factor this to be x squared plus 1 times x squared plus 1, which would be the only legal way of actually square rooting. Because if you FOIL this out, don't you have a plus 2x squared that isn't there?
You get an x cubed minus x to the 4th minus 1.
But even then it wouldn't be a perfect square because it'd be x to the squared plus 1, x squared minus 1. They're not the same. So I could factor it, but I couldn't square root. So either way, I can't actually tell you what the polynomial is, but I can tell you that it's a squared, and a squared over a squared ratio of leading coefficients because the degrees are tied. You have to be careful of the signs, but if we plug in positive numbers, that's a positive, positive numbers, that's a positive, so it's a positive 1, but we'll check that with trickier examples soon. What's going on down here, guys? Oh, top wins, infinity. E to the x is strong. There he is, right? What are you getting in your calculator? Hopefully something different. Hopefully something different. Negative 30, what'd you guys get? 5 e to the x all over 7 minus x to the 10.
So it's negative 8 to the negative 28.
Yeah, that sounds about right. How about negative 300? Aww, no fun.
Why no fun having?
Sorry, it's literally.
No, the calculator is no fun. Not Adam is no fun. You guys are rude. Anyway, coming back. If the very first one is negative 8 times 10 to the negative 28, what does that negative 28 mean?
A lot.
A lot of zeros. How many zeros?
28.
27.
27.
Because it has to make one decimal jump, right? And then it goes, okay. But it's going to be negative point and then 27 zeros and then 8. Well, probably not even 8, probably like 7.8. So then why are all of these just zeros? Because the calculator is like, I can't even show you how many zeros because it's probably in the 3 or 4 or 5 digits. Meaning, super tiny, meaning 0. But hold on, I thought e to the x was the strongest, and maybe you guys didn't realize this, was the strongest function out there. Exponential growth, everybody uses it to be like, things are awful, it's growing really fast. So how on earth does x to the 10th win? Can you guys go the other direction and go delete out all the negatives from the 30 and the 300 and the 3,000 and the 30,000? And what do you see then? 30 works. What do you get? Negative 0.0904. Okay, keep going. Sorry, it's positive 3.
1927.
For 300, it's 19.
Oh no,
Oh,
300 is error.
Party poopers. Okay, so we can't go that fast. Hold on. Can you go to 50? Is that going to give you a value?
Oh yeah.
Okay, what's it give you?
Negative.
How about 75?
Well, I got 2.7 even if
Oh, you do the fifth. That makes more sense. There was no scientific notation for this one, right? No, because it's 0.0. How about 75?
Negative 3 e to the 14.
You guys see it? Something very different is going on this direction.
Something really weird.
This was going closer and closer and closer to 0. E to the 5th, e to the 14th. Aren't those positive? AKA adding 4 zeros
So it's
and
going
adding
more and more
13
negative.
zeros. It's going more and more negative. It's decreasing without bound. So if I was to change this problem to the limit as x approaches negative infinity of, no, sorry, positive infinity, 5 e to the x all over 7 minus x to the 10th. That would be negative infinity.
Whoa.
How does that make sense? We'll come back to this after we talk about our degree test. Sound good? Because, okay, first of all, something very different is going on depending on what direction we go. And second of all, that's a negative, not even a positive. But let's look at these guys real quick. Finding limits at infinity. So just introducing the whole idea of plugging in. Why do I know for number one that the final answer, without doing any table, any math, not like cheating and using derivatives or anything like that, how do I know it's negative infinity? Just thinking of quote unquote plugging in infinity. Not infinity, but ever increasing values. Any ideas?
There's no denominator.
There's no denominator. There's no dividing away. And then Adam, what'd you see? If I was to talk about the degree of this, it's just a polynomial, and the degree, wouldn't I be looking at this term, guys? So if we were to do something called, it's a really snazzy term, the right end behavior model, because we're going to the right, we wouldn't actually worry about these little dudes because they kind of pale in comparison to the main guy. So every polynomial, in a sense, as you go to infinity or as you go to negative infinity, any function in general with like multiple terms, you need to pick out as you go to infinity or as you go to negative infinity, who's leading the way. Now this is kind of how like old battles were fought, right? Like in the sense of maybe even, let's go all the way back to David and Goliath. What was going on there with David and Goliath? Where were the armies?
On either side of.
Why were the armies here and you had two little guys duking it out in the middle? What was going on?
We're fighting to live.
Yeah, but how did that determine the outcome? Has anybody ever wondered that? Like
They were the best.
one little battle, they were the best. Well, it wasn't. That's the whole story, right? But they were their champions. So what they were doing is our champion's better. Like this guy is better than your entire army. Send someone. Send anyone to try to defeat him. And if you can't, your whole army better to surrender now. So they were sending out their champion. They were saying, this is representative of our entire army. This one battle will determine, right? So I want you guys to think of that when we do degree tests. So out of this entire polynomial, who's the guy who's leading the way as I go to infinity? Now, when I get in really close to really tiny numbers, if you guys remember, what's 1/2? X is really tiny, right? What's 1/2 to the 5th power? Wouldn't that be 1/2 times 1/2 times 1/2 times 1/2? What happens when you raise little baby fractions to high powers? Don't they get 1/2 times 1/2 is 1/4 times 1/2 is 1/8? Oh, he's not going to mean much for really tiny x's. But we're not looking at really tiny x's. What are we looking at? 10, 100, 1,000, a million. What happens when we raise those numbers to the 5th power? These guys pale in comparison. So I'm not saying he always wins, but as I go to infinity, oh yeah, he does. He's my champion. So we consider the champions. So if he's the champion, I don't care. He's going to infinity with a negative. Dun, 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 dun. No math was necessary. You kind of see it?
Yeah.
So what about this dude? Think infinity's not a number, it's ever increasing. So as I plug in bigger and bigger and bigger and bigger values, don't care, haha, done. How about this one? As I plug in bigger and bigger and bigger values. Why is it positive infinity? Adam, you explain. Don't even have to think about champions, there's only one. But. Okay, so what Adam's saying is if you don't like the square root, you can just think of it as a 1/2 power. Or you can technically, according to our limit properties, I guess you could think of the square root. There's this whole composition of function basic rule if you guys look at your flip book. I could take the limit and then square root it. And if you say infinity square rooted, I don't know, square root of infinity. But wait, infinity isn't a set location, it's an ever expanding. So what happens if you square root 25, square root 100, square root 1,000, square root 10,000, square root, aren't you still growing?
Yeah.
You're still growing. So how do we show ever growing? Now is it growing slower than without the square root? Yeah, it's growing slower, but it's still going to. That kind of introduces you to the idea of there are some infinite limits where there isn't much math involved beyond just kind of contemplating the universe, just kidding, not the universe, but contemplating the function and thinking of, okay, if infinity is ever expanding, you can plug into your table or you can think in your head. Get bigger and bigger and bigger and bigger and bigger and what's happening, get bigger and bigger and bigger, what's happening. I put it as quote unquote plugging in, but remember, infinity is an approach. It's ever increasing. Now there is, of course, the pre-cal way for when we have fractions, because that's when it gets dicey, because when we have fractions, then it starts to be, numerators want to grow, denominators want to divide. Numerators grow, denominators divide. Numerators, especially as we're going to infinity, is just like, let me add them, let's go, and the divider's like, hold on, pulling it back. So the idea that I did in pre-cal with some of you guys anyway, was the idea of champions, in that we're pitting these two guys against each other. If the numerator just wants to go to infinity, and if the denominator is like, I'm trying to hold you back, we have to figure out which one's more powerful. Is the numerator more powerful? Great, he's going to go to infinity or negative infinity. Is the denominator more powerful? Well, he's going to hold him back somehow. Maybe hold him all the way back to 0, or maybe just hold him back to some sort of constant. So 3 different cases, and all of them are pitting the top against the bottom, numerator against the denominator. And remember, even though each of them might have multiple terms, we're looking for the champions. We're looking for the term that will determine the magnitude, the strength, the power of the function as I go to infinity or negative infinity. But the problem is, we're just going to go ahead and talk about infinity right now, but we still have that really annoying example at the beginning of our notes, where there were different things going on, different directions. How were you supposed to know? Hang in there. But for right now, if the top wins versus if the bottom wins versus if there's a tie, right? Top wins, bottom wins, or there's a tie. But in the order of my notes, I guess. Top wins or there's a tie, or the bottom wins. If the top wins, I'm either going to positive infinity or negative infinity. And whenever we have positive or negative infinity, what do I say?
Check the sign.
Now this one's weird, because this one isn't a number over 0. It's another case for checking the sign, positive or negative infinity with horizontal asymptotes. But still the idea of plus or minus infinity, you gotta check the sign. Ironically though, this one's also going to be check the sign. Not because you always need to and there's always tricky problems, but the AP guys love to throw tricky problems in this number 2 case. It looks like Friday, but a weird day. Yeah, you saw it
It
too.
looks freaky.
Yeah, spooky season. Not quite yet. Still
Freaky
spooky.
Friday? That is spooky.
So,
It's less than 2 months away.
see, it's weird, because all the stores have fall, and Starbucks has pumpkin spice, and it's kind of
Actually, no.
Oh, ACT's on Saturday. Like, you're saying that.
Staff appreciation's on Thursday, that's what I'm looking for.
50, or I'd appreciate it.
Aww, look at that guy.
That's next Tuesday.
Okay, so what happens if they tie? Oh, wait a minute. Hold on. Pause. In context of the horizontal asymptotes. This just is 3 little dots. It's symbolic for the therefore. What's going on? Therefore, there is no horizontal asymptote. Why? Is the function stabilizing, converging towards anything, or is it just going?
Going.
It's just going. It's either going up or it's going down, but basically it's not being held back to a horizontal asymptote. So, no. Sorry. None. But this one, this is the ratio. Ratio of the leading coefficients. Now this one can be so straightforward and can be so easy, and yet, once again, I'm preparing you for the tricky ones that I know are coming. So I put things like, hey, it can get tricky, and hey, you better check the sign. But, long story short, there is a horizontal asymptote. And that horizontal asymptote is going to be at a constant. Some sort of constant. But a non-zero constant. But number 3, there is going to be a horizontal asymptote also. But it's going to be at 0 because whenever the bottom wins, that means he's going to keep dividing and dividing and dividing and dividing and eating away and eating away and eating away and eating away. And the whole rational function is going to head to 0 as I go to infinity. Nice thing is, no need to check the sign on that one. You're welcome. Why?
What can I say?
Positive or negative 0 is just 0. So the long story short of this is, there is a horizontal asymptote when, let me zoom in on this, there will be a horizontal asymptote. The horizontal asymptote will exist. Ooh, I should say asymptote or asymptotes. You better put that S in there and put it in parentheses. Sometimes there's just one, sometimes there's more than one, which I guess there could only be 2 because there are only 2 directions we're heading. I'm going to put a little S right there too. There could be none or 1 or 2.
Whoa.
But the horizontal asymptote exists when the limit as x goes to negative infinity is L, and I'm going to put and or positive infinity is L. So that's opening up the possibility of, oh, wait a minute, hold on, depending on the direction, you might find a horizontal asymptote, but you might find more than one. So I'm going to put L1, I'm going to put L2, because you might have more than one. Sometimes they're the same, sometimes it's only on one direction, and sometimes they are equal. Yeah, okay.
Why couldn't you have more than one horizontal asymptote?
Because horizontal asymptote is defined to be as the function decreases without bound or increases, I should say, as x decreases without bound or increases without bound, f stabilizes. If f is stabilizing to more than one value, it's not stabilizing. Does that make sense? And you can only go the 2 directions. We can't be going another direction. That wouldn't be horizontal. So all this leads us up to, okay, some problems can be tricky and there can be more than one, and we already saw an example of that. So can we go back and revisit that e to the x dude? What was going on in this guy, right down here, that made me have only one horizontal asymptote, but it only works from one direction? What was the case? Top wins, bottom wins, time. That is the question.
You're not that.
Can you guys try our quote-unquote plugging in? Can you try our quote-unquote plugging in? Or actually, maybe not quote-unquote plugging in. Can I show you a different variation for writing this problem? This would be the exact same thing as me saying the limit as x goes to positive infinity, as that idea of ever increasing, in the function, let's see if this makes sense. 5e to the negative x all over 7 minus negative x to the 10. Would you guys agree that they're the exact same thing?
Yeah.
I'm not trying to be tricky. Imagine the plugging in. Would they both end in the same result or the same consideration? Ever bigger numbers but negative. Okay, so it's going to be e to the ever increasing numbers. Yeah, that makes sense. and then negative infinity plugged in, but to the 10th power. Okay. So if these are the exact same thing, can I rewrite this? Because of a negative exponent? And can I write this to be 5 over e to the x? 7 minus, well, that doesn't make any difference. It's to the 10th power, so the negative isn't going to have any impact. Guys, who wins in this one?
The bottom.
The bottom, because everybody's down there. There's no one left up top. Or if you want to think about it, if you want to come back over here, you could also consider the graph of e to the x and question, what does e to the x do as I go to negative infinity? Just e to the x. Doesn't it get smaller and smaller and smaller and smaller as I go to negative infinity? So whether you rewrite it and think about it like this, the bottom wins because all the champions are down there. Or whether you think about e to the x and say, wait a minute, what do you do as I go to negative infinity? You go to 0? Well, you're no help. Fine, 0. Bottom wins, or your top champion, his Achilles heel. Kind of mixed analogy, but that's right. As I go to negative infinity, he loses all power. But what was drastically different in this one? Even though as e to the x goes to negative infinity, he loses all power. What happens as I go to positive infinity? He gains all the power. And in a way that the top wins. And then, wait a minute, why was it negative infinity if we're thinking of plugging in? I don't get it. He goes to positive infinity.
Are you going negative?
But 7 minus, this is always going to be a negative value, and a positive over a negative, guys, it was a classic check the sign. Plug in positives over positives, and as if this is increasing, well, that's going to be a negative value for all those huge values of x. So it's a classic check the sign. So was this possible without a calculator? Definitely. A lot of kids have gotten very confused, especially on this one, but also on that one, maybe making that a positive infinity and maybe making that a positive infinity when it should have been 0. So let's go see if you guys will get tricked on more examples. You ready?
Oh, thank you.
You're welcome. Yeah.
Can you go back to the bottom of the
What?
This one?
Yeah.
Yeah. Can I dual page? Do you think you can see? Oh, I don't know what I just did. Yeah, that was from algebra. What's the answer? Ah!
Oh my, wow.
I'm hitting all the wrong buttons. We should sue. I mean, don't, please. But. Okay. Ready, set, go. Write the examples, and just write them one by one. As you write the first example, like off top of your head, which case, and what would you say the answer is? And write example 2, off top of your head, which case. What would the value be? Right, third example, which case, what would the value be? Feel free to collaborate, feel free to talk it out, I don't mind. It's a cubed root over the entire function.
Sorry. I forgot my terminology, Kyle.
We should sue.
No.
So Andrea, is looking okay.
What are you saying?
Chanted. I know. I was confused. Kyle. No, it doesn't.
It's Chanton.
You guys are multitasking, right?
I'm writing it down, Steve.
Wait. Well, Kyle.
That was aggressive. Wow, I'm not ready for that.
I think 2 is 5.
I think these numbers.
I don't think I started out in school.
College?
When did you start driving?
Last year.
Had it.
After the last time, you opened your Oh, yeah. I forgot when I got there. That was
I
sophomore
started
year.
driving in March.
Oh, just I'm like, I can drive. I can get on my ears.
Oh, yeah, you always have to drive. That helps, I guess.
So,
At least having
but
a
on the
license,
show.
I mean,
Stop me. December 14th.
I'm gonna get my license before else. There's
I
no
was
way.
here to prepare for a year.
He said that, no, definitely.
I was.
Because she got there good, so she got like after the year passed, even though she didn't know what. Or you can wait until you're 18 and you got her take your test. I don't know. First semester my sophomore year in college, 18 freshman year. Are you good? You're 17.
Abby.
No.
I don't even know what that is.
Ow. What?
You guys solved them? Collaborate in your groups. Do they agree with your answers? Maybe yes, maybe no. Maybe they were tricky, maybe they were straightforward. Maybe they were tricky, maybe they were straightforward.
So let's try this one first. This one's equal. This one.
That's cute.
I'm gonna remember now. Good. That was. Oh. Why? I don't know why you. I thought you said John. I thought you said like so many things.
Yes.
Abby, you get on for the three best in the United States.
I skipped it.
Is that your goal? Your end game?
I have
That's
no
the end
idea.
game?
You have to punish me.
I don't know if I'll ever be rich enough to do
That's
that.
the end game right there. In the United States.
Well, cute is
Are they agreeing or disagreeing?
At least like 500,000.
I think last year before I you were like, you like Trump? Oh yeah, you wouldn't people like Trump. Whatever, be like, what? It was in Spanish, but people just talking about it. You just started speaking about me about Trump, and I was like, I didn't know him hard. Yeah, you remember that? We were with Tyler, and we were doing like some cool thing, and you were like, you like Trump? Yeah, no.
That is so great.
Wow, Adam.
Alright, you guys agree or disagree?
Agree.
It's like,
Questions?
Would that technically be like -1 point something over 2?
I mean, yeah, but you're not going to know the 1 point stuff.
No,
There's not going to be a calculator because they don't want you using it to use mathematics. Does that make sense?
Wait, how is it the negative? Oh.
See it? See it? There you go. There you go.
It's this. I forgot.
The second one, you said like your time have to be on the outside.
Well, I did it on the outside because it's the fully simplified form. And I'm assuming the multiple choice answers would have it fully simplified. So if you guys left it on the inside, I need you to realize it's the same as having it on the outside.
But they did
Because the cube root of -1 is -1. So then you're able to actually go that further step. Just like the cube root of 8 is 2. Kyle. Oh, sorry. I'm sorry.
So the cube root of everything inside
Yes. Yes.
Oh, it would have made sense because I was thinking if the exponent was even, it would have changed the positive infinity, but it's not a number 1.
If this was even?
No, positive. The number 1. The exponent doesn't matter.
No, the exponent doesn't matter because of the minus. Right. Because your champion is that guy. Yeah. See that the what? Kathleen?
So for number 1, it doesn't have a horizontal axis, but then you have to look at
Right. So I was having you guys solve the limits at infinity, but if you were to go further, there would be no HA on this one. This one would be a HA at y equals that, right? And then this would be an HA at y equals. Does that make sense? So how about this guy? Ready, set, go. So how about this guy?
Whoa, negative then. What's that change?
Whoa.
Yes, what's up there says, why do you need to check the sign?
Why you?
Don't press us hard.
Don't attack me.
You might like the hole.
Who already has it?
I'm gonna
3.
You guys agree?
But I don't know if it's negative or positive.
-3.
3 or -3? It can't be plus or minus because you're only going one direction. It can only stabilize at one value.
My heart still hurts.
Ah. So here's the struggle. If you were to take what we did over here, and if this one made sense with the cubed root, maybe you're like, I know how to do this. Haha, there's a 1 and I square root of 1. And square root of 1 is 1 and 3 over 1 is 3. Dun 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 dun. Ah.
-3.
The final answer is -3. Because if I was to show you the algebraic way of solving this, technically the square root of x squared is a absolute value of x. Now, not that we're actually going there, that's illegal. This is x plus 2, x minus 2. But the square root of a squared is going to be an absolute value linear function, which actually goes down to a plus or minus, which means, well, we have to consider what's here. But there's an easier way of thinking about it. Can't we think of our little trick of checking the sign? If I plug in a negative infinity on top, isn't that going to be a negative? And if I plug in a negative infinity, which into the champion, and square it, isn't that a positive? And a positive square root is a positive? Checking the sign will solve it for you, or will allow you to finish the problem correctly when tricky ones come, especially ones where you have square roots of even-powered functions. But, guys, I just want you to see that that might not just happen when you have quadratics underneath square roots. It might also happen when you have absolute values. Because you guys realize absolute values are also piecewise functions? Well, I just said that an absolute value, absolute values are tricky. So, you might have a couple more tricky ones that come and that show up. But maybe this one isn't too bad. I know, the aw, we ran out of time, right?
Aren't they the same problem? Oh, no, there's a negative.
Oh, yeah.
Do you guys see how this one would be a negative 3/2, whereas this one would be a positive 3/2? So Kathleen, how many different horizontal asymptotes are we going to have? Here's a case that we have one way and one the other way. Kind of like tangent inverse. One way and one the other way. And that one's one you have to memorize. Oh, don't worry. That one's just with e to the x that we already talked about. I might just take a page of notes on it tomorrow. Alright, cool kids. Homework is due tomorrow.
Yes.
This is just that weird exponentially dude. We'll take a little bit of notes on him.
Abby.
But that's okay.
I have an essay on Friday.
Alright guys, chat when I present those.
I just hurt my hair.
Oh my gosh. Okay.
Maybe.
Abby. Alright guys, favorite quiz on Wednesday. Get out here. Present bell ring.
What'd you say?
Sorry, we're having too much fun.
That's awesome. I just said that.